So I am talk about the today's session like sand, stones in terms of rocks. A project can be requires stones in the form of like aggregates. Stones are having various types of minerals composition. Stones having varieties types of mineral composition. At the same time, chemical compositions. But difference between whether it is stones and minerals. Minerals are homogeneous inorganic structures which are having a definitive chemical compositions and definitive atomic structures. At the same time, minerals are having various types of properties, whether like physical, chemical, and optical properties. So each and every mineral having all varieties of minerals are classification based on the chemical composition and definitive atomic structure. So there are uh, four types of classification. One is silicate group of minerals, non-silicate group of minerals, ore forming minerals, and clay group of minerals. So all varieties of minerals are having inorganic, homogeneous inorganic structures which are having a definite chemical composition and atomic structures. Whereas stones are can represent an aggregate of mineral grains. Stones are having an aggregate of mineral grains. Mineral grains, whether silicate grains and non-silicate grains, whatever it is, but we can find out silicate and non-silicate having using various kinds of testing tools, whether in geological applications, in geological properties, as well as in engineering properties also. Engineering properties, various kinds of materials to find out the material strength. And before that, to find the geological properties, all varieties of materials. Therefore, stones are various types based on the after formation of rocks. The main difference between stones with minerals, stones are having basically three types, whether igneous, sedimentary, and metamorphic rocks. At the same time, inorganic stones as well as organic stones are there. But organic stones are does not taking for as a construction materials, especially like road metal, as a concrete aggregates and railway ballast, etc. So organic substances they cannot using for these forms, whether road metal like concrete aggregates, railway ballast, etc. But which kind of rock is useful for the various engineering projects? So without stones, we are not a construction engineering projects. But how to find out the whether if it is three types of rocks like igneous, sedimentary, and metamorphic rocks, and what are their formations, like classifications, like structures, then their textures, like mineral compositions and megascopic characteristics, etc. Each and everything to find out the before selection suitable stones or rocks, various engineering planning. So the main investigation of the geology, whether if it is surface investigations and subsurface investigations, before planning the construction, planning, design, and construction procedure as per the building Bureau Indian standards, guidelines, and IS codes also. So there are difference between minerals with rock. Mineral is only one chemical composition with reference whether if it is silicate and other than silicates, whereas rock also having various kinds of minerals composing interlocking bonding with each other under the influence of like magma, under the influence of like sediments, under the influence of chemical active fluids with reference high temperature and high pressure, etc. So rocks are varieties of types of rocks, whether igneous, sedimentary, and metamorphic rocks. Igneous rocks again various types based on the formations like that: acidic igneous rocks, basic igneous rocks, and ultra basic igneous rocks, then intermediate igneous rocks. So why they are classified either acidic, basic, intermediate, and ultra basic? Because of only they are having percentage of silica. Acidic igneous rocks are requires various engineering constructions, whether if it is color and without color, whatever it is. But both of them among the color and without colors of granite rocks having silica greater than 60% of silica. Whereas basic igneous rocks between 40 to 60% of silica, and intermediate igneous rocks having 20 to 40% of silica, and ultra basic igneous rocks are having less than 20% of silica. So based on the silica having, we take various types of engineering constructions depends upon the only rock also composing silica concentration. Whereas other than two types of rocks like sedimentary with metamorphic rocks, so few examples are having silica is rich, and few examples of metamorphic rocks silica is also rich. So ultimately engineer can be selection suitable rock, various engineering aspects of projects, mainly strength and durability. So whether fine aggregates and medium aggregates and coarse aggregates, whatever it is, their dimensions also different, but strength is also fine, medium, and coarse of granite rock having strength. So hence geology will the study of the earth. It's also consisting of crust, mantle, as well as core. So surface and subsurface geological data, if required, construction of various projects whenever before plan, design, as well as construction procedure as per the BIS and the building bylaws. So petrology deals with the study of rocks. Hence, rocks are also classified various types: igneous, sedimentary, and metamorphic rocks. So only today I discuss igneous rocks. Igneous rocks are also formation with the help of solidification of magma. Solidification of magma. Magma nothing but silica. Silica, liquid state to convert to solid state. Igneous rocks are formations, two varieties, whether intrusive igneous bodies and extrusive igneous bodies. Intrusive igneous bodies are various types, and extrusive igneous bodies are various types. Extrusive igneous bodies like basalt, and intrusive igneous bodies, example of plutonic igneous rocks, granite, syenite, gabbro, etc. So there are various types of igneous rocks, mainly in intrusive igneous rocks and extrusive igneous rocks. Intrusive igneous rocks having silica is greater than 60% of silica, so that in engineering constructions. They can recommended based on the having silica, whether the essential minerals as well as accessory minerals also. Here, absent of CaCO3 for granite and present of CaCO3 for sedimentary with metamorphic rocks, especially for marble and limestone, laterite and shale also. So they are not recommended for in engineering constructions, especially like road metal, like uh, concrete aggregate and railway ballast, limestone and marble also. So marble only can using residential buildings in decorative purpose, and limestone can be using for manufacturing of cement industries. The limestone cannot be recommended for engineering aspect, especially in construction of like roads, railway ballast, etc. So that the mainly conversion between three types of rocks, whether granite, limestone, and marble. Marble is the metamorphic rock, limestone is a sediment rock, and granite is plutonic igneous rocks having acidic igneous rocks. So geological classification: igneous rocks are hard and non-porous, with porous having sedimentary like limestone, next grit, next gravake, etc. But igneous rocks are very durable without porosity, and their water absorption is less than 10%. So as per the building bylaws, water absorption capacity should be maintained less than 10%. So more than 10% of water absorption, durability is also decrease after completion of the projects. So whether sedimentary with metamorphic rocks, durability more or less more than 10% of water absorption. So whereas all kinds of igneous rocks except basalt, whether vesicular basalt and amygdaloidal basalt, they are also showing vesicles and porosity. They are showing more than 10% of water absorption. We are not recommended for in engineering construction, basalt rock especially in major construction of projects. So whereas sedimentary with metamorphic rocks, examples of few, porous at the same time water absorption is above 10% of above 10%. Meanwhile, they are formed from cooling of hot molten magma. The main examples of this classification: granite, which is consisting of greater than 60 to 80% of silica, having at interior earth, is at very high temperature, which may cause melting of silicate, slaying the rain. This hot molten magma mass is known as magma lava. This hot molten magma forces up to the earth surface in the form of volcanic eruptions, where it is solidify in the form of igneous rock. So volcanic rocks, hypobasal igneous rocks, and plutonic igneous rocks formation, three types. Volcanic igneous rocks, best example is basalt. Basalt availability on the nature, whether vesicular basalt and amygdaloidal basalt. Mainly, the two types of rocks also having wide ratio porosity and porous structure, so that gas can be transferred from top to bottom. The two elements of rocks we can't consider in engineering projects. Like that, composition of igneous rocks, mainly like mineral composition, whether if it is felsic and mafic rocks. Felsic rocks also having quartz, potassium feldspar, like plagioclase feldspar and muscovite mica, biotite mica. Whereas in mafic igneous rocks are showing biotite mica, olivine, pyroxenes, amphiboles. But different is percentage of silica. Mafic igneous rocks are having percentage of silica is nearly around 40 to 60%, whereas felsic igneous rocks are having more than 60% of silica. So as per the geological knowledge, there are various types of igneous rocks composition: felsic igneous rocks, mafic igneous rocks, ultramafic igneous rocks, and intermediate igneous rocks. The percentage should be like silicate group of minerals. So a rock also composing whether if it is silicate group of minerals and non-silicate group of minerals. Silicate group of minerals are nothing but essential minerals. A rock also composing should have compulsory, whereas non-silicate group of minerals, whether if it is present or without present, depends upon the composition and interlocking bonding with each other, various kinds of grains and their shapes, and mutual relations between grain sizes and their shapes. So based on the grain size and their shapes and mutual relationship between grain size and glassy matter, there are two types of categories of igneous rocks of textures, like equigranular textures and inequigranular textures. Equal means all kinds of grains of minerals composing interlocking bonding with each other, whether if it is quartz, potassium, plagioclase, olivine and mica, then garnet, more or less equal grain size and their shapes, known as, and we can treat the equigranular textures, and opposite grain size and their shapes in equigranular textures of igneous rocks. Like that, classification of rocks, geological classifications, physical classifications, and chemical classifications. Geological, various types, and physical, various types: stratified, unstratified, and foliated. Chemical classifications: argillaceous, siliceous, calcareous, rudiaceous, and ferruginous. Argillaceous, siliceous, calcareous, and rudiaceous, then ferruginous. Chemical classification of rocks. Then their description. Chemical classifications: argillaceous. Argillaceous are having alumina and clay as a principal constituents, but absent of silica. The examples of argillaceous rocks: laterite and slate. All clay group of stones belonging to this in group. Example of laterite and slate. Siliceous rocks, main constituents silica as a principal constituents. These stones are durable stone apart from the like argillaceous, then ferruginous, calcareous, and arenaceous. The examples of siliceous rocks are granite, quartzite, and sandstones. Granite is superior from quartzite with sand. Sand and quartzite. Granites are using various engineering constructions. Calcareous rocks, main principal constituents CaCO3. They are called as calcareous rocks, but they are having CaCO3 and magnesium carbonate. They also contain some proportions of siliceous and clay matter, but they are not recommended for calcareous rocks in engineering aspects because of CaCO3 and magnesium carbonate. Whenever and unfortunately adding few drops of dilute and concentrated acids, they can react. They can react because of having a rock CaCO3 and magnesium carbonate of principal constituents, and some part of siliceous, then clay matter, but minor. But major, suppose siliceous and clay matter is nearly 10 to 20%, and remaining 80% having of calcareous rocks CaCO3. So high calcium carbonate CaCO3, medium CaCO3, and low content of CaCO3. Example of limestone. Slowly and fast and medium, they can react with dilute and concentrated acids. So that does not recommended for an engineering constructions. So they can recommend it for only manufacturing of cement to industries. Next, physical classification, stratified rocks. So they are having available on the earth stratified or layers. All sediment rocks are essentially stratified, and few examples of metamorphic rocks are showing by the stratified and unstratified, depending upon the parent rocks. So mainly, why they are stratified, whether if it is sedimentary with metamorphic rocks, because of reason having less percentage of silica. So each and every various kinds of metamorphic and sediment rocks are having CaCO3 and partial amount of siliceous and clay matter. But igneous rocks are does not consisting of CaCO3. They are not stratified and unstratified rocks. So they are having mainly silica, so that they are not undulations, faulted ruptures, and faulted then joints and unconformities structures. The examples of stratified rocks: slate, sandstone, and limestones. So really uh, showing on the limestones, slate, and sandstones are stratified structures. Unstratified, these types of rocks do not showing sign of stratification and cannot be easily split into thin slabs or layers called as unstratified rocks. So example of all of igneous rocks, essentially unstratified and metamorphic rocks, maybe either stratified or unstratified. So the examples of unstratified rocks are granite and basalt and trap also. And the geological classifications, earlier we show the igneous sedimentary with the metamorphic rocks. Metamorphic rocks. Like the rock cycle, various weathering factors, weathering, erosion, transportation, and deposition, sediments, sedimentary rocks, metamorphic rocks. Metamorphic rocks are formed with the help of pressure and temperature and chemical active fluids from the pre-existing rock. So in the microscopic observations, granite rock also showing various grain sizes, unequal sizes, in equigranular textures. The rock also having varieties of mineral composition, but different sizes. And felsic, mafic, ultramafic, intermediate rocks and their examples. Thank you, sir.
Thank you, sir. Thank you very much. Now I request participants, if you're having any doubts, you can please ask. Okay, sir. Thank you very much. So thanks Venkateshwari sir for sharing his
Yes,
knowledge with
yes,
all the
sir.
participants.
So
Thank you.
thank
Thank
you,
you.
sir, for providing for this, giving my opportunity. Thank you, sir.
Okay, sir. Okay, sir. And I thanks all the participants for listening the lecture. Okay. So with this we stop the session. Thank you. Thank you, one and all.
Thank you, sir.